Today we're talking about an introduction to systems. I actually have your worksheet from today because there's a lot of words, a lot of information on it that I didn't want to have to repeat and rewrite just so you could hear them and see them again. So the situation they're giving us is two other cyclists on the ride were Helena, age 73, and Jessica, age 19. Helena rode at a constant rate of 1 mile per 4 minutes, and Jessica traveled at a constant rate of 1 mile per 2 minutes. Because Helena is in the over 70 age group, she has a head start of 5 miles. Jessica starts at the beginning of the 24-mile route. We're going to look at a couple of questions from this, show you how to set up a system of equations. In the first one it says, write the algebraic rule for the function that describes the relationship between the time in minutes and the distance from the starting line. The distance from the starting line is going to be how far along the race they are. So we're going to take these one at a time. On this first one we have Helena. Her distance, I'm just going to put as an h, so I can tell that this is her equation. Now, she's riding her bike at a constant rate. Okay, that means it's a linear equation. Her distance is going to be equal to 1 mile every 4 minutes. That means in 1 minute she goes 1/4 of a mile. That way 4 minutes go by, she's gone 1 mile. And we don't know how many minutes she's been riding right now. So that's our other variable. That's what's going to make this a line. Now because she's 73, she's in the over 70 age group, she has a head start of 5 miles. That's going to be her y-intercept. It's her beginning point. So it's plus 5. Jessica, on the other hand, I'm going to represent her with a j. And her distance is going to be equal to, she goes a constant rate again. It's going to be linear, 1 mile every 2 minutes. It seems like she'd be getting out way ahead of Helena, but Jessica is 19, so she's starting at the beginning line, just where she should be. And that's it for her equation. When you graph these on the calculator, you can't use an h and a j and an m. You have to go into y equals, and you're going to type in 1/4 m plus 5. Remember, on the calculator, you put the fractions in parentheses, and it'll be 1/4 x plus 5, and then we'll have parentheses 1/2 x on the other one. Now, the way that they're going, if I just graph this and it's on a normal setup, we'll be able to see that Jessica's going faster, but we won't see the place where they intersect yet. If it comes to a spot like this on the calculator, usually you're going to have to reset your window. We're going to push window. We're going to change our x minimum to 0. We don't need to know about negative because they're not going to ride for negative minutes. We're going to change our maximum to, let's say, 100. We're going to change our y minimum to 0 because they're not going to have a distance less than 0. And our y maximum, we can make that 100 as well. When we regraph this, we have a positive graph, and we can see a point where they would cross on there. Much, much easier. Okay, you can use the table function and you'll be able to work number 2. You'll be able to give the distances that they've gone in an appropriate number of minutes. I would suggest going up by 4 so that way you'll always have an even numbered answer, not have to deal with fractions or decimals. When it tells you to use the graph to determine the solution on number 3, this is where you can use what we already learned in class. You go to second and calculate, and you're going to find number 5, the intersection. You hit enter, enter, and enter, and your calculator will tell you 2010. That's all it tells you is 2010, so we know the answer is 2010 on number 3. But number 3 also tells us to explain the meaning of our answer. Well, in this case, 20, the x value, this m is where our x would be. So that means in 20 minutes, if I could spell minutes today, in 20 minutes, both riders have gone 10 miles. You should be able to use this information to help you a lot on the front and finish out the back of this paper.